All right, so we want to find the midpoint of segment AB, and we want to find the length of segment AB, which is the same thing as finding the distance from point A to point B. The first thing I would do for either one of those things would be to plot them. So what I'm going to do here is I'm going to put this on a coordinate plane and plot the points. So who can help me with plotting the points, where all this stuff should go? Jimmy?
For A, go left 2.
Okay, so I'll just make a mark where I think -2 should be.
And then up 7.
And then up 7, so I'll make a mark where I think 7 should be. And so then that point A is going to be where?
Right, with these 2.
Yeah, so straight up from the -2 and straight over from the 7, and that's going to be point A. All right, and then what's that?
-2 should be close for in.
You think so?
Yeah, because you're 4. It's gonna be double that, right?
Yeah, I think it'll be all right, don't you? I mean, if I double that right there, it'd get me to right about there.
Yeah, that's 4. I mean,
So I'll go to 4 here. Oh, okay. I see what you're saying. So I'm actually going to scale the x-axis and the y-axis a little bit differently. So the x-axis, the spaces are going to be a little bit more spread out. But if you want it to be square, so the same scale on both axes, yeah, I probably should have the -2 in further. Good point. It is okay, though, if you scale the axes differently. So with -2 being over here, as long as I scale the x-axis the same, so +2 would probably be right about here, so +4 would be about right there. So it looks like the scale on the x-axis is about twice as big as the scale on the y-axis. So we'll have 4 there, and then where should -1 go on the y-axis?
Closer in.
Yeah, pretty close. In fact, I'm going to put the 4 above because we're going to get a point right where I had that 4. So there's -1 on the y-axis, so it's going to be right here. So there's point B. Okay? Now what? Jimmy? Not yet. Yeah, let's connect the dots here and actually draw that line segment. So there's line segment AB. So the two things I want to do is find the length of that line segment, and I want to find the midpoint of that line segment. So Jimmy, how are we going to find the midpoint?
You add up the x's and divide by 2.
Okay, so we're going to average them, right?
Yeah.
So to find the x-coordinate of the midpoint, I'll call that xm. We're going to add them and divide by 2. So tell me what to write down, Jimmy.
-2 plus 4 divided by 2 equals
Equals what?
1.
Okay. And how about the y?
7 plus -1 divided by 2 equals 3.
Right, because 7 plus -1 is the same thing as 7 minus 1, right? So we have 6 divided by 2 is 3. So then the midpoint is going to be where?
It's going to be 1, 3.
At 1, 3. Now looking at the x-axis, about where should 1 be on the x-axis? If this is the origin and this is -2, it looks like this is going to be -1 and the same distance to the right would be +1. Yeah? So right about there. So there's 1 on the x-axis. And then 3 on the y-axis is going to be just a little bit less than halfway from 0 to 7. More specifically, it's going to be 3/7 of the way, right? So at 1, 3, we're going to get the point right here. And does that look like that could be the midpoint? Yeah. Okay, so we've got the midpoint at 1, 3. I'll go ahead and put a box around that, showing that's a final answer there. Now let's find the length of segment AB. What are we going to use to do that? There's 2 ways we could do it. We did it 2 different ways yesterday. Brittany, which way do you want to do it?
The distance.
Okay, you want to use the formula? Okay, go ahead and tell me what to write in the formula. I'll start with the big square root.
Okay.
You go from there.
Parentheses 4 minus -2
and then another parentheses.
Yeah.
Okay, so that's x2. X2 is 4. X1 is negative 2, so that's x2 minus x1. And then what do we have to do with that? What do we have to do with that parentheses? Okay.
Oh, I said times like to the
Times 2?
no, like to the second.
To the second power, or squared, right?
Yeah.
Okay, so we have x2 minus x1 squared plus,
Plus parentheses negative 1 minus 7. This is the second power.
okay. So then we need to simplify this here, Brittany. So tell me, what is 4 minus negative 2?
6.
Okay, so we get 6 squared. And what is negative 1 minus 7?
Negative 8.
So we have negative 8 squared, and then the square root of all of that. And what is 6 squared?
36.
And negative 8 squared?
64.
Yes, and that's a positive 64 because a negative times a negative is positive, right? Okay, so we have the square root of 36 plus 64. What is 36 plus 64?
100.
And Brittany, what is the square root of 100?
10.
10. So that means that the length of that segment is 10, right? Let me see if I can squeeze that in here. Well, that's just ugly.
That's fun.
That's like the one thing I've learned in this class is how to do those little things.
Those little bracket things?
Yeah.
Cool, at least you learned something.
I know.
Alright, so the length of segment AB is 10. That was one way to do it. No, that wasn't the only way we did it yesterday, was it? Jimmy, you want to go? Actually, you've already done one. Malik, you want to walk us through the other way? I'm going to erase all of this. Oh, not all of it. There we go. I'm going to get rid of everything up to here. Okay, so Malik, what was the other way we did it?
Well, I drew a triangle, made a triangle with that line going down to the point where it meets the 4 in a way, and then draw another line going horizontal to the point of the 4.
Okay, I'm pretty sure I know what you mean by that, mostly because I know what we need to do here. But what Malik wants to do here is draw a vertical line going down from A until we get to negative 1 on the y-axis, and then a horizontal line from there over to B, right?
Yes,
Okay, cool. And what kind of triangle have we created there, Malik?
a right triangle.
Yeah, this triangle right here, I will highlight it. This triangle right here is a right triangle. Okay, so this right here, since it is, since it's an angle between a vertical and a horizontal line, we know that's a right angle. Okay, Malik, so how can we use that to find the distance here?
Well, I counted it from the where it starts at the 7, and then I counted all the way down to where it meets at the negative 1, which was 8.
Okay, so the distance between 7 and negative 1 on the y-axis. So the length of this segment right here, this vertical segment, is going to be the same as the distance along the y-axis for that same, for those same coordinates. So we're going from 7 to negative 1. In the picture here, I think this is actually a pretty easy thing to do. What is this distance right here? 7. And what is this distance right here? 1. So especially when we cross over an axis, we can just add those two numbers together to get the total length. So that line segment there has a length of 8. Okay? And doing the same thing, Malik, what do we get for the length of that segment? 6. So this part over here has a length of 2, since it goes to negative 2 on the x-axis, and this part right here has a length of 4. So adding those together, we get 6 and 8. Now, what kind of triangle do we have here, Malik?
A 3, 4, 5.
It is a 3, 4, 5. 8 is 2 times 4. 6 is 2 times 3. So that means our length here, our distance, is going to be 2 times 5, which is 10. And we get the same answer. no matter which way you do it, whether you use the distance formula or if you're using the right triangles, you should always get the same answer both ways. So neither way is correct. When it's a special triangle, I think this way is always easier when it's a special triangle that we know, because we don't have to do the Pythagorean theorem. If this were not a special triangle, we would still have to do the Pythagorean theorem, and we would end up doing about the same amount of work. So this way saves work sometimes. It doesn't save work all the time. So I think maybe you should pick which way you like better. If you like using the formula better, that's great. If you like using the triangles better, that's great. Or if you're comfortable with it, switch back and forth. Look at a problem like this and say, well, that's going to be a special triangle because the distance between the x's is 6 and the distance between the y's is 8, so I know that's a 3, 4, 5 triangle. And it takes a little bit of practice, I think, to recognize that, but if you get good at it, then you're going to save yourself some time. So this is the distance formula I gave you yesterday. Obviously, you don't need to copy it down again, but you do need to get your notes out from yesterday because we need to finish a couple of those examples. So on this particular example, what's the first thing we did? Yeah, we plotted the points, right? So the point 2, 3, I notice here that I'm going to go up to 7 on the y-axis. I like that 7, don't I? So I'm going to go to 2, 3, and negative 1, 7. So again, I'm going to use a different scale on the axes here just to make it look a little bit better. So there's the first point, and negative 1, 7 is going to be right about there. So there's our second point right there. And if we connect those points, we get a segment that looks something like that. Okay, then what's the next thing we did? We did it two different ways, kind of like we just did in the opener here. We did it using the distance formula, right? So what did that look like? Somebody rattle off the distance formula for me. Jimmy, go ahead.
Square root of, like, parentheses, -1 minus 2, parentheses, squared, plus 7 minus 3 squared, parentheses.
All right, and we got -3 in here, and -3 squared is 9. We got 4 here, and we got 4 squared is 16. 9 plus 16 is 25, and the square root of 25 is 5. So we ended up getting 5 this way. Okay, and then we did it a different way. That was the distance formula method. We did it a different way, and what did we do the other way? Anybody remember the other way we did it? Did we do it the other way? No? We just did the distance formula and that's it? Okay. Oh man, I lied to you in the opener then. I guess we did do it a different way in a different example. Okay, I'm sorry. I was thinking of the other example that we did. So the other way we could do this then, let's go ahead and go through it. We did the same thing in the opener. Is what? Make a triangle. Make a right triangle. So I'll get you started with it. It actually doesn't matter if you go down and to the right first, or if you go to the right and then down. It really doesn't matter which way you go. I usually draw my triangles below it just because it's a habit. That's the way I've always done it. But it would be okay if you drew your triangle over here instead, like this. Okay, it really doesn't matter as long as you have a horizontal and a vertical line. You okay?
Oh, I'm fine.
Is Matt distracting you?
Start it, man.
Now what? How do we find the length of this leg right here? That's the difference between what two numbers on what axis? It's the difference between 3 and 7 on the y-axis, and that's going to be what?
4.
Okay, and this distance right here is going to be the distance between what two points on which axis?
1 and 2.
-1 and +2. So I could find that by doing 2 minus negative 1, and I get what?
3.
3, so that side has a length of 3. And this one's really easy now. What kind of triangle is this? It's a 3, 4, 5 triangle. Again, we get the same answer whether we use the distance formula here or if we draw a right triangle here. So either way you want to do it is okay with me. Questions about this one? All right, I'm going to give you the next 3 examples, and I'm going to give you about 5 minutes to work through those before we move on to slope. First thing we're going to do is plot the points, right? So once I plot the points, what's the next thing I need to do? Yeah, connect them. Draw that line segment, right? We want to find the length of this line segment here. That's our goal here. So the distance between the points using the distance formula finds the length of the segment. So who wants to pick one of the ways and tell me what to do? Either way first. Doesn't matter. Okay, I'll do one. Or Evan, did you want to do one? You're kind of groaning over there like you're thinking about it. Tell me how to find the distance.
You can do 6 on the long side. On like the,
Okay, so how'd you get 6 for the length of that side?
it's the distance between, not the distance between, the distance of -1 and 5. How far away from each other?
Oh, so you're doing along the x-axis. This one.
Yeah.
Okay, so that's going to be 6 there because that's the distance between 5 and -1. So we get 6 for the length of that side. Okay? And how about along the y-axis, Evan?
That's 6.
It is 6 as well. Crazy, right? So that's the distance between 4 and -2 along the y-axis. And we're going to get 6 for the length of that leg. Now, this is a special triangle. It's not a Pythagorean triple, but what kind of triangle is this?
1 minus square root of 2.
It's called a 45,
Oh, yeah.
45, 90 triangle. Okay, so if we have a right triangle where both legs are the same length, then it's a 45, 45, 90. The scale factor here from our base 45, 45, 90, which was 1, 1, square root of 2, would be what? What's the scale factor? We multiply by 6, good. So what do we get then for the hypotenuse? 6 square root of 2. Alright, so by drawing the right triangles, we get 6 square root of 2. What if you didn't remember that this is a 45, 45, 90? What could you do? That doesn't mean we can't do it. What would we do, Malik?
Divide the 6's by 6 and do 1 squared plus 1 squared equals x squared.
Okay, so you're simplifying it. Let's not simplify it, though. I like that. And then you would multiply by 6 again, right?
Yeah.
Okay, you could do that. Or you could just say 6 squared plus 6 squared equals d squared, and then use that to solve for d. So you have 36 plus 36 equals d squared. That means that d is equal to the square root of whatever 36 plus 36 is. 72. And you'd have to factor this.
Yeah, but that'll take
2 times 6 times 6. It's not that long, right?
pretty long.
Which means we have a pair of 6's and we get 6 square root of 2. Okay? So if you recognize that it's a special triangle, 45, 45, 90, you can use that. If you recognize that the 6 and the 6 have a GCF of 6, or a common factor of 6, sorry, you can factor out the 6, solve the triangle, and then multiply it by 6 again. We did a couple of problems like that when we were doing Pythagorean theorem. Or the other thing we could do is use the distance formula. Anybody want to set that up for me? Or are you going to make me do it?
I got it.
You got it.
Sam, go.
-5. I mean, 1 or -1 minus 5 or 5. Okay.
If we're truly going to do x2 minus x1, I would call this x2 and this x1. But it really doesn't matter. You could do -1 minus 5 or 5 minus -1.
Alright, plus parentheses 4 minus -2 squared
Okay, what is 5 minus -1, Sam?
is 6.
Okay, so we have the square root of 6 squared plus, what is 4 minus -2?
Is 6.
6 squared. And what we really have here is the same thing we had there. The math from here on down is exactly the same as it was when we did the Pythagorean theorem. Why is that?
Because it's the same thing.
Because it's the same thing. The distance formula comes from the Pythagorean theorem, right? Remember that from yesterday? Okay. Who's having fun?
You are.
Good answer. All right, so on this one, we're going to go 4, -1. And you got a point there. We go -2, +1. Get a point there. I'm just going to do this one of the ways. So I want to find the length of that segment. So which way do you guys want to do it?
Shortest way possible.
Hey, you gotta straight up.
Actually, in this case, it would be just as quick to use the distance formula as it would the Pythagorean theorem, and the reason is the side on the left is going to be what? What's the length of this side going to be here?
2.
That's going to be 2. What's the length of this side going to be here?
6.
6. Did we see any kind of special triangles that had sides in a ratio of 1 to 3? No. So this isn't going to be a special triangle of any kind. We're going to have to either do the Pythagorean theorem or the distance formula, both of which are pretty much the same amount of work. So let's do...
The diameter.
Triangle.
the diameter.
Not the diameter.
Malik wants to do the diameter.
Distance.
Distance formula. Okay, so we're going to do the distance formula. And actually doing the distance formula, everything that we drew in the picture there is not really useful to us. We don't really need it. It just kind of gives us a visual of what it looks like. All right, so the distance formula, we have d equals the square root of x2 minus x1. What's x2?
-2.
Minus x1.
4.
Okay, squared. Plus y2. Evan, keep going.
1.
Minus y2,
-1.
or y1, sorry. Squared. Okay. What is -2 minus 4?
6.
Say -6.
whatever.
Okay, -6 squared. It would give us the same answer as 6, though, wouldn't it? When we square it. Okay, and 1 minus -1?
I think it's like -2.
Positive 2?
2.
Okay.
2.
So that's going to be the square root of, what's 6 squared?
36.
Plus 2 squared?
4.
Okay, 36 plus 4 is 40. And we simplify that. That's going to be 4 and 10. Square root of 4 is 2, so we get 2 square root of 10. You would get the exact same thing if you did the Pythagorean theorem. Right? Did anybody do it that way? Draw the triangle and do the Pythagorean theorem? Did you get the same answer?
Yeah.
Okay, cool. All right, last one. Let's do the distance formula without drawing a picture. Since in the last one I said if we do the distance formula, we don't need to know what the picture looks like. And then I'm going to show you something. So who can fill this out for me? x2. Jimmy, go.
3.
Minus x1.
3.
Squared plus y2.
-3.
Minus y1.
2.
Okay. What is 3 minus 3?
0.
So we have the square root of 0 squared and -3 minus 2.
-5.
-5 squared. All right, 0 squared is 0. -5 squared is,
5.
and 0 plus 25 is And so the distance is 5. Now, that's what we get from the distance formula. I think there's a much, much, much easier way to do this, and it doesn't even involve a right triangle. Why?
Involves adding
No?
3 plus 2 is 5.
Okay, so subtracting a negative. Yeah. You're close, I guess, when you said adding. If we plot these points here, we go to 3 on the x-axis, we go to 2 on the y-axis, and negative 3 on the y-axis. So we get a point there, and we get a point there. What kind of line segment do we get here?
Straight.
They're all straight. All line segments are straight.
Vertical.
Vertical. So we get a vertical line segment here. Since it's a vertical line, how do we measure distances along a vertical line? We did it yesterday. Well, you could just measure it, or you could, Sam said it earlier, we could subtract the negative. We can just do this distance right here is 2 minus negative 3, which is 5, and that's it. There is no x component to that segment. Since it's a vertical line, there's no x involved here, so the length of that segment is just the distance along the y-axis, and that's it. Pretty cool, huh? Okay, that's enough. That's all the distance formula stuff. We're actually going to start slope now. I'm just going to kind of introduce it. We're going to get into the slope formula. Just like yesterday's notes, we're going to do a couple examples and we'll finish them up tomorrow, not yesterday. That would be weird. And then once we finish those tomorrow, you'll have some time in class to work on the 3 worksheets that I will have given you by that point, on the midpoint, on the distance, and on the slope. All right, so let's talk about slope a little bit. Who can tell me what they know about slope? Alicia. Okay, so there's a way of finding slope that's called rise over run. We'll talk a little bit more about that later. Who can tell me what the slope tells us about something? Cody? Okay, so it tells us at what angle a line is going on a coordinate plane. So first of all, the only things that have a slope, or the only thing that has a slope, is a line. Or when you get into calculus, you actually talk about the slope of a curve. But the slope of a curve changes as the curve changes. Okay? So when we're talking about the slope, we're talking about something about a line, a quality of a line, or a property of a line. So I want you to tell me this. Who's going to win this race? If both of these guys here just kind of let themselves go, and assuming that the friction on both slopes or both hills is the same, then who's going to get down first? Brittany? The guy on the right. Why? Yeah, his hill is steeper, right? Yeah. How about here? Who's going to win this one? The guy on the right. What's different about this problem from the last problem?
They're going to hit each other.
Well, they did run into each other there. The guy on the right got a concussion because he was just sitting there. It's, important safety. Yeah, never mind. How about this one? Actually, from your perspective, it may look like one line is steeper than the other, but if you're looking at it from straight on, they're actually exactly the same steepness. Kind of weird, isn't it? Evan, from your perspective, which one looks steeper?
The right one.
Evan, from your perspective, which one looks steeper?
The right.
The one on the right. Sam, from yours, which one looks steeper?
On the right.
The one on the left looks steeper.
The one on the right was
Longer? I mean, the one on the left longer?
Never mind. It doesn't matter. That's a perspective thing. The both of those hills have the same steepness, so they tie. Okay? So the slope tells us 2 things. It can distinguish, if we're talking about the skier there, it'll tell us which line is steeper. So it tells us 2 things. It tells us the steepness of a line, But we also have to distinguish between slopes like this. These two hills, even though both skiers finish at the same time, they don't have the same slope. So the slope tells us two things. It tells us how steep the line is, but it also tells us what?
The angle.
That would be the steepness. Cody? Okay, so the positive or negative aspect of the slope is going to tell us what direction the line's going. Okay, so the slope tells us not only how steep the line is, but also which direction it goes. Who remembers positive and negative slopes? I want you to give me a thumbs up if you think this is a positive slope and a thumbs down if you think it's a negative slope. Everybody should give me one or the other. Thumbs up for positive slope, thumbs down for negative slope. Okay, I agree. It is a positive slope. Who can tell me why it's a positive slope? How you know it's a positive slope? Malik?
Because it's starting from the bottom and going up to the right.
Oh, I think, okay. Malik got the key here. As you go from left to right, it's going up. Now, it's not true that the line is just going up, because what if I'm going this way? Then I'm going down. So we're going to go from left to right, and as we go from left to right, the line is going up. How about this one? Thumbs up or thumbs down? Okay, it is a negative slope, right, Aspen? Yeah. This line has a negative slope because as you go from left to right, it is going down. How about this line? It's in the middle. It's not positive, it's not negative. What number is in the middle of positive and negative? 0. Okay, cool. How about that line? Just shout it out. Negative. How about that line?
Undefined.
Okay, now this one's a little bit tricky. There's two lines here that are in between positives and negatives. Okay, so let me ask you this. Is the slope of this line a big slope or a small slope? Small slope. And how do you know it's small? Because it's not very steep, right? So this is a small slope because it's not very steep. What if I make it even less steep? Then the number is going to get, or the slope is going to get even smaller, right? All right, so if it gets so much less steep that it becomes this line, as the number gets smaller and smaller, it becomes 0. Okay, now looking at this line here, does this have a big slope or a small slope? We know it's negative, but it's pretty steep, so it has a big slope. It's going to be a big negative slope, but it's a big slope. If we were to make this steeper, would it get bigger or smaller?
Bigger.
It would get bigger. So if we made this so steep that it becomes this line, how big is it? Don't say undefined. Undefined is not a number or a quantity.
No.
Infinite.
This car.
I was gonna say that's what it said was undefined. Like,
No, undefined is not a number.
well, that's
Or
what
nor a number concept. I'm not there yet. Calm down. Calm down.
Simmer down.
Okay, thank you, Evan. So if the slope gets steeper and steeper and steeper until it becomes a vertical line, the slope is actually infinite. Now, as a convention, instead of saying the slope is infinite, we call that undefined. Okay? And the reason... What?
We had it right?
But I was asking you for a number, not a definition. Okay? So infinite is a numerical idea. It's not actually a number. But as a number increases and gets bigger and bigger and bigger without bound, if it's unbounded, it's infinite. So this line here has an infinite slope, or you could say it's undefined. And that line right there, positive or negative? It is positive. Okay, so these two lines are the ones that we said are neither positive nor negative. I kind of talked about why. This image right here is what kind of helped me remember which one's 0 and which one's undefined. If you picture the skier on each of these slopes, what's going to happen to the skier on the left when we release him? He's just going to chill out there, right? He's not going anywhere. What's going to happen to the skier on the right?
Break all his bones in his body.
He's going to fall off the cliff and he's going to become undefined. We don't like to talk about life and death in here, but we'll say he's undefined. So once I release these guys here, the guy on the vertical line becomes undefined.
He's gone.
Okay? The guy on the horizontal line doesn't move.
He's scared.
He's 0. That would be me. I'm more of a cross-country skier type person. Okay, so we're going to do one example here, and then we will we'll save the rest for tomorrow.
Whoa.
We've kind of hit the idea of slope a couple of different times in here. I think it was Alicia that said that there's an equation. It's not really an equation, but it's an equation that helps us find the slope, which is what, Alicia? Rise over run. And that's the way that I'm going to kind of picture this here. So just like the other examples, the first thing we're going to do is plot the points. So 1, 0 would be right there, and 3, 4 is going to be...
You don't even need to plot it though. You just figure out the points. Yeah, but
Now, I want you to notice that the directions say find the slope of the line containing the points. So this is not a line segment now, but it's going to be a line. It can be a line segment. It can really be any part of a line. So it could be a line, line segment, or a ray. But we want to find the slope of this line right here. Any ideas how we could do that? Alicia said that slope is going to be... First of all, why did I use the letter M? Nope. M stands for slope. Seems kind of weird, but in the math world, we use the letter M to represent slope. So the slope is rise over run. Now let's talk about what we mean by these terms real quick. What does rise mean? It's how much we're going or down. This is the key. A lot of people want to say, well, it's not going up, so it's not rising. Well, if you're in an elevator and I ask you how many floors you go up, but you actually went down 2 floors, what would you say? No, you wouldn't say you went down 2. Let's put it mathematically. You went up -2 floors. So a rise... Now, you wouldn't actually say that probably. You would say, no, you're wrong. I didn't go up. I went down. But if we wanted to say how much we went up, but we're going in the opposite direction, we can throw a negative on there to show that it's the opposite. So rise is up or down. Run is left or right. So let's do this real quick before we get out of here. Don't put your stuff away, please. I'm almost done, I promise. So if we start here, how far do we have to go up until we get even with the other point?
4.
We go up 4. So that's going to be a rise of 4, and since we went up, it's positive 4. And then how much do we go to the right to get even with that point? 2. So our slope is 4 halves, right?
no, 1.5. 2.
Simplify it. 2. Okay, I'm done.